Today we are going to be learning multi-step equations, and before we do that we're going to review a few things that we have learned the past several days. Just to remind you, the variable is the unknown value represented by a letter. The constant is a fixed number, a number without a variable, or as I say, just a plain number. The coefficient sits before the variable, therefore it is being multiplied by the variable. For two-step equations, we are going to first add or subtract by getting rid of all of our constants. Then, secondly, we're going to multiply or divide to get rid of our coefficients. Remember that to get rid of a constant, you add the opposite of the constant. You add the opposite. For example, if we look at these examples on the screen, our constant is positive 5, so we're going to do the opposite by subtracting 5. What we do to one side, we do to the other, so we're left with negative 2x equals negative 5 minus 5. A lot of people want to say that's 0, but it's not. It's negative 5 plus negative 5, so it's negative 10. And your answer will be positive 5. In the next example, the opposite of our constant is to add 5. We're left with x over 3. Negative 1 plus 5 is 4. X over 3 is like division, so we're going to multiply by this 3 in order to get rid of it, and do that to the other side. Our answer is 12. Now on the video, you guys can pause it at any point and do the problem and then go back and listen to me. I would suggest that actually. I'm just going through these so that you have them to look at and confirm the work that you have done. The opposite of our constant in number 3 is to add 6. We want to get rid of that 6, so we're going to add 6. We're going to do that to both sides. This will cross out. We'll get 2x equals 20 and divide by 2 to get x equals 10. On the last one, our constant is the number 10, and it is positive, so we're going to subtract 10. If we subtract 10 to that side, we subtract 10 here. These will cancel out, and we will have negative 3a equals negative 5 plus negative 10 is negative 15. Remember, this is the same thing as adding the opposite when we subtract, so it's same sign, add and keep. We'll divide by negative 3. Our answer will be positive 5. So this is a review of two-step equations. This would serve as the warm-up for today. Then I want to remind you about dividing by fractions. When you divide by a fraction, it's the same as multiplying by its reciprocal. Reciprocal, R-E-C-I-P-R-O-C-A-L. And you learned this in 6th and 7th grade, that if you divide by a fraction, it is the same thing as multiplying by the reciprocal. So if we look at number 1, we have 2/3 x equals 8. One way we can do this is to say, well, if I have 2/3, I'm going to divide by 2/3, which means that I will also do that on this other side. And then we would have to say, in 6th grade, we learned that we keep it, change it, flip it. It would be 8 times, we change division to multiplication, and we flip the fraction. And 8 times 3 over 2 is 24 over 2, because remember, you can slap a 1 under here. And 24 divided by 2 equals 12. So that process shows that we divided by 2/3. Honestly, if you'll start doing it like this B, it will be quicker and easier, and you'll get used to it. So instead of showing it as division, okay, we've got our problem here. We're just going to show that we're multiplying by the reciprocal, which is 3 over 2. So we're going to come over on this side and multiply by 3 over 2. What we do to one side, we do to the other. These cancel out. You can cross cancel them, or you can multiply and get 6 over 6. They go poof. And here now we have 8 times 3 over 2, just like we did up there. And our final answer is 12. Now this looks like a little typo on number 2. I want to clarify that that is just one bar going across. So on this one, I'm going to write it so it'll be a little larger. Oops. We have, let me get my pen working here. We have negative 3/4 C equals 15. Now we know we're going to multiply by 4/3, but if we have a negative sign, then we are going to make sure that we multiply by negative 4/3. And we're going to need to do that on both sides. I'm sorry, I will get better with writing with this pencil, but this is still new for me, so I'm not really great at it. So we're going to multiply by negative 4/3. And these will cross out. 15 times negative 4 would be negative 60. This would be 3 on the bottom, 1 times 3. And our answer for C would be negative 20. Okay, now you go ahead and try the third one. Pause the video. I'm going to pause the video and come right back. So in the example number 3, we are going to multiply by the reciprocal of negative 1/5, which will be negative 5/1. So if you have a negative, you keep it negative when you multiply by the reciprocal. Then we have negative 20 on the right. We'll also multiply that by negative 5/1. These cross out, and we're left with K equals negative 20 times negative 5, which is 100. Now for these next examples, as you'll see, two-step equations with rationals, these follow along with the first video on today's lesson, video number 4, and it is titled Two-Step Equations with Rationals. So I will attach my work as a PDF, but the video actually goes through these 4 problems, so I'm not going to go through those. Again, right here, you can look at my work on the PDF. Okay, trying to get to the next page. I'm going to pause just a moment. On the back side of your notes, I'm going to give you a few reminders about distributive property. You always, if there's distributive property within a problem, you're going to distribute first. And what does distributive property look like? It looks like these 4 examples right here that we're going to review. Basically, it's a value that sits outside a set of parentheses, and inside the parentheses you have more than one term, okay? And you're always going to take this outside number and draw your little arrows like this. We learned this in 6th and 7th grade. So in this problem, you're going to have 7 times 5x, and then you're going to also have 7 times 3. And you don't always have to write that first line. You just kind of have to know that's how it works. In the second problem, you've got negative 3. The lady in the video suggests circling it. It's going to multiply times 2x and then times negative 8. Okay? So after we distribute, let's look at line on this first one. This would be 35x plus 21. The second step is to combine like terms. Okay, and then we're going to isolate the variable using inverse operations. But this first line of 4 examples is just practicing distributive property. There are no like terms, so this one is done. You cannot combine 35x and 21. Negative 3 times 2x is negative 6x, and negative 3 times negative 8 is a positive 24. And you're done because these are not like terms. In number 3, you're multiplying 1/2 times 8x. 1/2 times 8 is 8/2, or 4. You bring down your x. And 1/2 times negative 20, you're going to bring down your negative. And you'll have 20 divided by 2, which is 10. It's not a very good 10. It looks like an 18. There we go. And number 4, looks kind of like a little typo. Make that go straight across. You're going to have negative 2/3 times 9k. Then you're going to have negative 2/3 again, multiplied by -6. So when you multiply -2/3 times 9, -18/3k, and then -2 times -6 would be a +12 divided by 3. -18/3 is 6, -6, and then 12/3 is 4. And these are not like terms, so you would be done. So those are just practicing distributive property. Now if you'll, the video number 5 is the example, has these 4 examples, these next 4 examples worked out. And so I'm not going to work these out right now on this video because it's on the other video. But you can play that video and see those problems there. Okay, so we're going to skip down those 4 examples, and we are going to look over here at the bottom down here, equations with variables on both sides. And this will be the last video for today. The first step is that you're going to distribute if necessary. And what that means is if there is no distributive property in the problem, then obviously you don't distribute. Like if we look at number 1, I don't see any parentheses here. So there's nothing to distribute. In fact, in these 4 examples below, number 4 is the only one that actually shows a distributive property in the problem. Then you're going to combine all like terms, if there are any, on each side of the equation. And just to remind you what like terms are, if you have 5a minus 8a, that equals -3a. It's like saying 5 apples minus 8 apples equals -3 apples. 12p plus 8p equals 20p. That's like saying 12 pickles plus 8 pickles equals 20 pickles. Or if you just have plain old numbers like 50 plus 20 equals 70. Those are considered like terms. What's not a like term is if you have something like 5a plus 8. You would just stop right there. There's no like terms to combine because the 8 does not have an a on it. And then lastly, you are going to move the variables to one side and the constants to the other using inverse operations. And these 4 examples are on the final video for today.